Hello, everyone. I'm really grateful to see all of you here. It's really a great season, a great session to have all of you get this opportunity to be able to be part of these sessions that are going to be part of our norm as women, and especially when we look at the possibilities that are there. Please mute your mic. Kindly, let's mute our mics. Please, let's mute our mics kindly so that we can be able to hear each other. We are starting the sessions, and I'm taking this opportunity to welcome you here. Grateful to see so many ladies interested about the e-mobility space and learning about electric cars. And grateful for African EV. The meaning of African EV is African EV electric vehicles. And this technical training that is virtual is just one of the many others that are going to follow. Our role is just to encourage you and to continue to ask you to join. I'm not going to take much of the time. I will be introducing the speakers for the day. My name is Faith Waraki. We can connect at LinkedIn profile. Just type Faith Waraki at the LinkedIn profile. You will find me at the LinkedIn profile. I am a woman in e-mobility and really championing about female participation with African EV in their business associate structure, and really passionate about girls in STEM and women in STEM. About 18 years in the auto industry space, wealth of experience on cars, engineering, and all that. But much more mentoring young girls and mentoring women in STEM and girls in STEM across the universities in our country and across Africa and beyond. So we will continue to learn about each other. If you look at the screen, we have the onboarding intros for this session. We encourage you not to miss these sessions because we are checking the people who are in here, because once we get to certification, we will check whether you attended the virtual training or not. Very soon, we will be coming to your nations for the technical training, the practical training. So please endeavor to create time for these sessions. So onboarding to all female electric vehicle technical training with African EV. African EV this is an innovative training program developed by African EV, aiming to enhance learning, reskilling, and upskilling within Africa's workforce. Its primary goal is to accelerate the adoption of electric vehicles, EVs, throughout the continent. Additionally, the program addresses the challenge of inadequate after-sales services and maintenance due to a shortage of qualified personnel. African EV is organizing Cohort 1, which is this one. You're in Cohort 1 of an all-female electric vehicle technical training program across various African countries to address the gender gap in the EV sector. We all know that there is a huge gender gap. But I want to add that apart from the huge gender gap, we have an attitude gap. from the women and the girls and also the men. So my prayer is that we do not get to fall in the category of the attitude gap, because we must take up these roles and responsibilities. So the training aims to increase the number of knowledgeable women with a deep understanding of electric vehicles and the e-mobility sector. So in today's topic, we will be having our first facilitator, Executive Director, GAD Ashiagbor, introducing the EV history, past, present, and future. And really, I want you to listen keenly to understand that this is the future. We are living in the future. We are not even living in the present. We are living in the future. And as women, we cannot be ignorant that we have a responsibility at the table of the transition that is happening. So he will be talking about the EV ownership experience. He will be talking about the introduction to the EV history, electric vehicle history. And he is the executive director, African EV, really passionate about supporting the women and the girls in the electric vehicle space. So welcome, Gad. Kindly
Hello.
take the podium. We welcome you wholeheartedly. You can see the ladies are clapping and welcoming you in the chat. Thank you.
Thank you very much, everybody. It's a pleasure to be here once more. This has been the maiden edition. We did realize that. I'm sorry if my brother is a bit windy. Outside where I was. This has been a maiden edition. We realized that there was a bit of some confusion yesterday, so we created a WhatsApp platform so that in case, because we noticed that some people are more comfortable communicating on WhatsApp rather than the mail. So thank you very much. I'm very excited to be here. I want to, before we start, I want to share something with you. So if you go to the WhatsApp group, I think I can meet you in the chat. Let's see. There's a link I'm sharing there. Someone can share it in the chat over here. When you go menti.com, then there's a code. Please enter the code and then you answer the questions that are there. We'll go step by step. Okay, please, can you all see this? Good. Good. So please, everybody try and answer the questions. You can see the responses as you are giving the answers. So right now, in one word, what comes to your mind when you think about electric vehicles? So the way this works is the answer that requires the most is the one at the center. So that means that most people are thinking about sustainability, people are thinking about technology, people are thinking about clean energy, conservation. Wow, interesting. Future, battery, efficiency, hybrid, charging, affordability, reduce carbon dioxide emission. Wow, that's impressive, ladies. Let's see. Let's 69 responses. Wow. Okay. Let's see. Okay, that's a very interesting. Okay, sustainability. Sustainability seems to be the clear winner in this poll. Let's go back and see what else is possible. Thank you very much, ladies. I think we get a clear idea. Most of you are thinking efficiency, sustainability, clean energy, future hybrid, reduce carbon dioxide emissions. Fantastic, fantastic, fantastic. Now, without much ado, let us get into it. Okay, please, can everybody see my screen? Wait, can you see my screen, please?
Yes, we can see.
Okay, so
Yes.
good morning, good afternoon, good evening, wherever you are on the African continent. I suspect that some of you may not even be on the continent. Like we heard earlier, my name is Ashiagbor, and I'm the executive director of African EV. I'm also a teacher and a farmer, e-mobility advocate, e-mobility enthusiast, and an e-mobility consultant. So if you look at that list, it's like my interest mainly is in electric mobility. I like stories. So there's this story here that I want you to read about a man who was working on an oil platform one day, and then he went to sleep, woke up in the middle of the night, his whole platform was on fire. And this is a platform in the middle of the sea. So you have to take some decisions. You can either, it's a petrol rig, you can either wait on the rig and die, or you can jump into the ocean. Either option is not appealing. But this man invariably decided to jump. And somehow he survived the jump. And he lived to tell his story. The moral of the story is that there are times that we are faced with two bad choices. And like one choice will guarantee certain death, and another choice may result in death. In this instance, he chose the option that may result in death, and he was able to survive. And there are also situations where we are forced to make radical choices sometimes. And this story was told by the CEO of Nokia in 2011 when they were undergoing a major crisis. They were being disrupted by Apple's iPhone. Today, Nokia is no more in the telecommunications space. So this speech that he gave with this illustration was not able to help them. Okay. So I think we spoke about African Navy already. These are our other directors. So we have 3 gentlemen and 2 ladies. We have myself, I'm Nigerian. We have Rudat, who is Kenyan. Sorry, I'm outside, so I think the plane is maybe interrupting the. We also have John Bisingo, another Kenyan. Then we have Yanchit Duncan, Nigerian, as well as Tolu, also Nigerian. What this session is meant to do is to give you a context about e-mobility. We are fond on our continent of jumping into things without any proper context. And when you don't have a proper context, what invariably happens is that there are gaps in your understanding and there are gaps in your application. So there are things that you ought to be able to see and to do that you missed out on. So this session is very, very, very important. But the two sessions today are all meant to give you context. Next week, we go a bit more technical. So please bear with me. If at the end of this program, you understand these three things, I will consider you an immobility expert. Number one is that what we are talking about is not an evolution, it's a revolution. An evolution is something that takes place over a long period of time, but a revolution, the time is more compressed, it's faster. It's faster. That means that you ought to be able to react faster. And the speed of the time is relative. In one context, 1 month may be short. In other context, 1 month may be long. It depends on your preparedness and readiness to adapt. That's the first thing. The second thing that all of you, I pray you'll be able to understand is that when we talk about electric vehicles and e-mobility, yes, the number of the cars are important. But what is more important is the miles or kilometers driven. In other words, if there are 10 cars in Zambia and 2 of them are electric and 8 are the normal petrol and diesel cars we all know. And at the end of the day, those 2 cars, so at the end of the month, have traveled 1,000 kilometers combined. And then the 8 petrol or diesel cars travel, let's say, 500 kilometers combined. The impact of those 2 electric vehicles is far, far more than the impact of the 8 petrol or diesel cars. This is a very, very critical information to understand. Otherwise, no matter your sector, when your organization begins or your business begins to be impacted by e-mobility, you may be caught back because you'll be looking at the wrong thing, which is, oh, how many cars are on the roads? No, the right thing is, how often are they being used? Then the last point is that it is here. It is not going to happen. It may not happen. It may not take a while to happen. It is here and it is now. The example I can give is in the year 2000, we had this whole Y2K thing. In the year 2000, most offices in Africa had typewriters. But as at that time, the typewriter was dead because of computers. It is just that we have not yet woken up to that reality in our part of the world. And these particular cohorts, about 753 people applied for this, and let me say 580 were selected, divided into 2 cohorts. And you all come from different backgrounds. Some have an engineering background, some have humanities background. Some of you are working in engineering companies, some of you are working in regulation, some are in catering, all manner of backgrounds. Because this thing affects the whole breadth of society. We all need to move. The things we need to wear need to be moved. The food we eat need to be moved. So that is the heart of that. Now, our talk today is going to be divided into three thematic areas. So the first is on the automobile industry with respect to our dear continent, which is Africa. But that's not the beginning of the conversation. The beginning of the conversation is about movement, like I alluded to earlier. Human beings since time immemorial have moved. We move ourselves and we move the things we need to use. The places we have to live, we have to move the materials to build our houses. So movement is fundamental to our existence. We move to go and drink water and whatnot. And at the beginning, it was animal powered. Either we are using our feet or we are using other animals to move and transport things, physical atoms. Over time, we move to simple machines, mechanical machines, like we saw this galley that the Romans, for example, were using to row. It is a simple pedal to move. But this is also an advanced form of animal transportation. Then we now move to engines, where an engine is a device for converting one form of energy into motion using mechanical means. So the first form was external combustion engine, where you burn a lot of fuel and use the energy of that fuel to move something in an open container. And we went to the internal combustion engine, which is what we are living with today. All the cars on our roads, basically, most of the cars on our roads are internal combustion engine powered cars, where we have an enclosed cylinder and we burn a source of fuel in it, either petrol, diesel, kerosene, gas, whatever. And of course, we also have other types of engine like the jet engine and then the rockets, but those are not of prime importance to us today. Now, when it comes to the engines, you see that apply to road transport, because we can move on land, sea, or air. Our interest is in road transport. And road transport normally is via vehicles powered by this internal combustion engines. For most of Africa, rail is not really a major part of our transport mix, as you will see very soon. What this picture is showing you is about how efficiently human beings can be using various types of cars. You see passenger cars, top left. The cars are plenty, that's traffic. Now you see the number of people that these cars are moving on the upper right corner of this chart. Then you see those same people, lower left corner, put together. The picture is telling you that moving people in, let's say, a mass of public transport vehicle is more efficient than moving them individually in different cars. But that creates traffic, it wastes fuel, as well as resources, because all these cars have to be bought and all that. And that's going to be one of the key themes of these sessions, which is efficiency. Efficiency. As I alluded to earlier, this is a chart. And please, in these sessions, you'll be having a lot of fact-based information. Information supported by data. And it's one of the key things that we would like to leave you with by the end of these sessions, where you always use data to inform or back your assertions. If you look at this chart, we're just telling you how we move on our continent. You see the chart for various countries. Basically, most of our goods and we ourselves, we move about using public transport. This is very, very important, especially in the context of the previous slide. It is also important to understand that when we talk about transportation, we are actually talking about energy. We all know that energy is the ability to do work. The reason why that is so is because transportation happens to be one of the primary expressions of energy. On your right, on the chart, you see Maslow's pyramid of needs. Faith, I think some people are trying to join the call. Can you add them, please? Let's come. If you look at Maslow's pyramid of needs, the base is physiological needs, the fundamentals, the need for food, clothing, and shelter. But what he took for granted is that all that rests on transportation. Either you are traveling for the food, or you are traveling for the materials we need for the shelter, and all that transportation also rests further on energy, because without energy, you cannot transport anything. So, if Maslow's pyramid of needs conceptualizes for us how society is structured, then it means that the fundamental or the foundation is energy. And one of the expressions of the fundamental expression of the energy is transportation. Now, the question then becomes, what form of energy are we talking about? And that is largely dependent on the type of engine we are using to move either ourselves or whatever. Because although all engines aim to produce motion, they all don't have the capacity to work with all types of fuel. Number one. And number two, the mechanisms they use to convert that energy into fuel are quite different. When we look at cars or vehicles, road vehicles on our roads, we can categorize them into four broad segments or sectors. We have the micro-mobility products, so things like bicycles, motorbikes, and the tricycles, which are becoming more and more prevalent on our roads, fall under micro-mobility. Then we go to the passenger vehicles, the type of cars that people buy for their personal use. Then we have the light commercial vehicles, like the Toyota Haze kind of cars, this 10-seater, 20-seater, 18-seater kind of buses. Those are the light commercial vehicles. Then we have the heavy duty vehicle. These are the construction equipment, the mining, the buses, the couches, those big ones. And one interesting thing about this graph is that when you start from micromobility and you move clockwise, the cost increases clockwise as you go clockwise until you get to the heavy duty vehicles. And this translates directly into how we use this on our continent. So you see that on our continent, most public transport is the light commercial vehicles. You see the minibuses, a lot of the minibuses are prevalent. We have the passenger vehicles, and the passenger vehicles are normally 20% of the cars on our roads because they are the upper income and the bourgeoisie people who can afford them. The rest of us, we are using public transport, or we have our motorbikes, bicycles, and tricycles. All right. This is a very, very important chart. The blue is the total number of cars in the world for every given year. As you can see, it keeps increasing. This chart is not very, very current. Right now, we are about we're going to 1.4 billion cars. Huh? The red is Africa. If we take all the cars on our road in the world, if we take all the cars in Africa, comparatively, you can see how insignificant we are, both brand and new on our continent. And these cars also tend to be older because we are buying secondhand. We don't have money. This is very, very important because
Hello,
it
Gad.
explains quite. Hello?
Hello, Gad. Would you be a bit
Yeah?
louder? They're saying they can't hear you, some of them. Would you be a bit
Oh,
louder?
okay.
A bit kindly?
Okay. Can they see me though? Hello? Can you hear?
Yeah.
Is it better?
I can see the screen. Maybe the ladies would confirm by lifting their hands.
Can you see my face?
Yes, we can see your screen and the presentation.
Okay. Okay.
Yeah,
All right.
many of them
So,
saying they can see. Great. That's great.
okay.
But
So
your
I was
voice
saying
is
that
breaking.
when you look at the slides, okay, the slide just tells you the insignificance of our vehicle markets in terms of numbers is quite stupendous. What this chart is telling you is that if there are 100 cars in the world, Africa will have one of them will be from Africa. The other 99 are from different continents. That is embarrassingly small. Now, these are the number of cars sold annually. This is different from the number of cars on the road. Let's say if there are 100 cars in Kenya, then every year Kenya buys 5 cars. Then it will come to add to the number of cars already there. And maybe that year, 2 of the cars are retired. So it will be 5 minus 2, that's 3. So that 3 is what you add to the number of cars already on the road. So the number of cars on Kenya will increase by 3. So the number of cars sold is quite different from the total number of cars already existing in the country. That was what the first chart was about, the number of cars in the country. This one is about the number of sales. In this one too, Africa is around the same 1%. You have to stretch your eyes to see it. Most times when I show people this chart, they think it's an error. It is not. That is our reality. Okay. Now, what I did here is that instead of comparing Africa to the whole world, because it's so embarrassing, I decided to compare Africa to the three largest markets. Okay, we have North America, uh, that is Canada, USA, and Mexico. Then we have Europe, the ones, the eco zone, plus Britain, and then a country, China. So we have three. America is the North American continent. Then we have Northern Europe. Then we have China as a country. Even with this further breakdown, they are still struggling. Number one. This suggests you that if you are a VW and you want to design the next Passat, it will make sense to design either for North America, Europe, or China, and then try to adapt that car for the African market. It will not make sense for you to design with Africa in mind as your major market, because we buy small amounts of cars. Another interesting thing about this chart is China. I want you to watch the trajectory of China from the beginning to the end. China was behind Europe and North America, but at some point it overtook them. So today, the most significant auto market is China. Most of the car companies make most of their profits in China. That means that anything that happens in China has a significant effect on the rest of the automobile industry. Very, very important. The third thing that you have to observe from this chart is that Africa has relatively stagnated. Our share of the auto market sales has not significantly, our percentage share has not significantly increased in all that time. It has hovered around the same zone. We have maintained our level. Very, very, very important inference to make. And then the last point about this is that the total number of cars sold in the world is declining. During the end of 2017 going, the numbers are reducing. Let me go back to the previous chart so you can see it well. And of course, 2020, there was COVID. So COVID made things worse. But generally, the trend has been a reduction of car sales. If you're talking about sales and it's not working, total number of cars on the roads is not working. Why don't you also look at the production of the cars, the places where the cars are made? When you look at that data too, we are not being helped. So, total number of cars on the road, Bobo. The number of cars sales, Bobo. The number of cars produced, same Bobo. We have a problem. Now, what we try to do is to compare the whole of Africa to different countries that also produce cars. You have China, USA, Japan. When you do the comparison, the whole of Africa compared to individual countries still bobo when it comes to production. However, we are not saying that there is no production. There is some production in Africa. So these charts, we are trying to see the countries that are producing the cars, where the places that most of the cars are coming from. And you can see on your left the places where the cars are coming from. And then on your right, the places that most of the sales are also coming from. What you notice is that most of the countries with production tend to have more sales because of the effect of policy. Like, for example, South Africa has banned the importation of used vehicles. Why? Because they have an automobile production. So that also encourages sales. And this is quite important because for every single manufactured automobile job created, production job created in the country, there are 20 other jobs that's we have a factory employing 100,000 people directly. We have to multiply that number by 20 to get the total employment created by that automobile factory. It is very, very significant. And we seem to be playing with that opportunity to our detriment. Now, I suspect that as we're talking about all this, some of you may be thinking about, oh, when it comes to brand new cars, yes, but when we're talking about used vehicles, how will we buy more? That may appear to be the case, but there's a catch. So if we take the whole African continent in aggregate, we buy between 800,000 to 1.2 million cars, brand new cars every year. Now, the total number of used cars we also buy also tracks around that region. That doesn't make sense because if you are Kenyan, Zambian, Ghanaian, Nigerian, you normally know from experience that there are more used vehicles bought every year than brand new ones. The reason for that seeming anomaly on the continental level is because of South Africa. For every 10 brand new cars bought in Africa, 8 are bought by South Africans. So the other 2 is left to be shared for the rest of the continent. And then those 2, for every one of those that are bought by the rest of the continent, the rest of the continent will also buy 8 used ones. I hope that makes sense. I'll repeat that again. For every 10 brand new cars bought in Africa, 8 are bought by South Africans. The rest of the 54 countries will share the 2 among them. And for every one of those 2 cars that are bought, so for the 2 cars that the rest of the continent will buy, the rest of the continent will also buy 8 used vehicles. So at the end of the year, the continent as a whole will have bought 10 brand new cars and we also bought 10 used cars. Okay, so if let's say a particular year Africa has bought 1 million brand new cars, we are likely to buy around 1 million used vehicles. We add it together, we get 2 million. And the global automobile market totally annual sales ranging between 70 to 100 million cars every year. Now, All this that I have explained to you in chat, this is a summary of it. And the summary is this. Africa has a population of about 1.33 billion people, on par with China, India. America has 300 million. Europe has 444 million. But all these other countries and regions have way bigger population. And there are also other calculations with that. Apart from having bigger numbers, you notice that China is one single market. India is one single market. Europe, even though they are different countries, function as a single market. North America is one single market. But Africa is divided into 55 fragmented markets that are all unsustainable markets. Everybody have their own policy. Everybody has their own regulation. Everybody has their own duty regime. It's bizarre. And on top of that, we don't have money, which is shown by our GDP per capita, which is how come even the cars we can afford are the used ones. So we have a problem. If you don't have production, what you can use to get a strong position in the market is your market. And we have contrived to divide our market willy-nilly. And one of the opportunities presented by e-mobility is the opportunity to function in some respect as a single market. What this does potentially is to create the opportunity for all of us who may be doing anything in the space, not transfer whatever we are doing in one country across the rest of the other countries on our continent without stress. And the opportunity is now when our markets are not appetizing to a lot of global players. Okay. We move to the next section of our talk today, which is electric mobility. Please, if you have any questions on the first as a part of the presentation, of Africa and the global automotive industry, please, you can drop them in the chat. You can also drop them on the WhatsApp. Free to read them, and then I will try and answer them. So the question is electric transport. What are we talking about? Just a few years ago, there used to be a lot of negative perceptions about e-mobility. This is a piece of quote from various newspapers and media houses about electric vehicles. At the time, it was seen as a high polluting, unsustainable, unsexy thing. And the reason why, I'm sure that this is going to be the killer. The next session with Jochen, I think a lot of the questions basically boils down to the barrier to e-mobility. People have questions. I'm sure that a lot of you ladies have a lot of questions about, oh, how do we charge this? This, how does it work? Will it electrocute me? Can it be used on our roads? This, that. People have a lot of questions. And these questions sometimes create fears and hindrances to these people that even if they have the ability to buy or use these cars, they don't want to. I have been at this for a while now, I think I got into this in 2012. What we see is that all these concerns tend to be there have been barriers, and it can be classified into three. And I designed this, I came up with this diagram to simplify it for everybody. Well, sometimes the whole thing sounds complex. So there are concerns about price. The concern about price is not just the price of purchasing, but the price of insurance, price of if you are buying from outside, importation, duties, homologation, price of roadworthiness, all manner of things. All of that go into the cost of the vehicle, price of electricity to charge the products. Then there are concerns about infrastructure, our roads, the charging station, and availability of electricity, charging standards. So, for example, when you go take your car to the petrol station, most people don't think about it. I'm sorry if my background is a bit noisy currently. Most people don't think about it, but no matter the car, you pick the dispenser from the fuel station, put it in the tank, it just goes. You don't have a situation where when you put it in the tank, it is the hole is too small and the hole is too big. That is because of standards. Every car manufacturer knows that the hole for that thing has to be a particular size. And every manufacturer of the fuel dispenser knows that my plug has to be a particular dimension in order to fit into that hole. But when it comes to electric mobility, we are like at the beginning of the smartphone era. There are different types of chargers, different types of connectors. So if you're not careful, you have so many adapters. You can go to this charging station, but you cannot charge your car because your plug cannot fit here, or your plug can fit there. But the protocols they are using, the system of rules they are using, it's not the system of rules your car uses. Or in Ghana, we have a different system. Togo, our neighbor, has a different system. Tanzania and Kenya have different systems. Lots of confusion. That is infrastructure. Then, of course, we have after sales support. So, how readily available are the spare parts? Are there qualified and competent service technicians? I have this horror story of somebody bought an electric vehicle. Then he traveled. When he traveled, somebody in the house wanted to use a car. He couldn't start the car. They called him that the car is not starting. They said, "Oh, it's a problem." He said to the repairer. Went to home in Accra. He said some mechanic said that they can repair this car. Send the car there. Oh, the people discovered that it's the battery. But the guy called and informed them, oh, you should check the battery. They said, oh yeah, it's a battery, it's a battery. Now, for an electric vehicle, we have this normal battery, like the one in the petrol car, the one to light the roof of your car, to start the car, those kind of things, to power the fan and ventilators and stuff like that. Then we have the battery, the other battery, the big one, that actually is used by the motor to move the car. These people, instead of working on the battery, which is used to start the car, because that is how we are struggling to open the car and start the car, they went to drop the actual battery, the battery pack of the car, rendered the warranty of the car void, number one, and number two, spoiled the battery on top. So all of a sudden, this man had to go and buy another battery. Well, he bought one of these expensive EVs for 25,000 US dollars. Now, In Africa, that is the price of a new car, brand new, Sierra, because of a lack of competent repair and service people to work on that car. That was his price that he had to pay. So all the questions you may have, and that you'll be asking, I'm sure as the session goes along, fall in this three categories. Now you notice that I've drawn another box around that. This box represents policy. What you will see is that these three things, they are like a triangle, right? Ideally, you want to reduce the size of the triangle. That means that you have to do it uniformly. And policy, the right policy, has the power to do that. Okay. Another way to look at this, which is actually more evocative, is to see it as a three-legged stool. But you see that that three-legged stool, if you have one of the legs of the stool, it will become unbalanced. Nobody can use it. If you want to reduce the height of the stool, the best thing is to reduce the height of all the three legs, if not simultaneously, then almost simultaneously, so that at least it can be useful. There will be times that one will be a bit down than the other one, or the two will be a bit down than the third, but at least there's a balance. Very, very important. Now, there is a question I get often, which is, oh, the electric cars, yeah, they are a new thing. They just came recently. This, that. It is not true. Electric cars were there from the beginning. In fact, they came before the internal combustion engine, or we call ICE, internal combustion engine. And the two types, middle type variation of the ICE engine, which is the petrol engine and then what? The diesel engine. This is a chart of various cars in America. So many years back, the year my grandmother was born, 1900. You see that we have steam cars, we have electric cars, and we have gasoline cars. Gasoline is petrol. The electric car was first conceived by a fellow called Robert Anderson in 1832. But in 1886, Carl Benz, the founder of Mercedes-Benz, conceived the first car. In 1893, the first road test of a petrol car was conducted. Car insurance was first done in 1896, 98. And this car insurance was quite interesting because it was somebody, there was no insurance company was not insuring cars. They were quite new. The main business they were insuring was these wagons. So what this fellow did was that an American, he said that he wanted to insure his car. So he went to a car insurance company and got an insurance policy meant for wagons for his car. So that was what he did. Okay. And then the first time somebody died through an accident was in 1899. And then Ferdinand Porsche of the Porsche company was the first person to do what we call today a hybrid car, where he combined both an electric motor and an internal combustion engine in one car. The car can use both. We'll talk a bit about EVs near the end of our presentation. And then, of course, what actually made the electric vehicle, one of the things that made it fall behind the petrol or diesel engines is the car starter. Some of you may have watched videos, or those of you who are old enough, this ancient cars that you have to put a metal bar. You have to put a metal bar in the snout of the car and wind it before the car will start. That is because those cars don't have a starter, which is also actually a small electric motor invented by an engineer from General Motors called Catherine. So you have on the screen, you have the picture of the first, the schematic for the design of that motor. And then beneath that, you have electric vehicles being charged in those days. And those cars were all using lead acid battery, like what you have in most of the cars we have now. But of course, we are not as advanced as our current lead acid batteries. Now, what are the types of electric vehicles? Someone tell me what, sorry? On our roads today. An electric vehicle is simply a car that has an electric motor, that has a controller, which is a device to regulate how fast or how slow that electric motor goes, and that has a battery, which is a container for electricity. That's a fuel car. So an electric motor will take in electricity, change it into motion. An internal combustion engine will take in either petrol or diesel and change that into motion by burning. The electric vehicle does that using electromechanical means. Now, when you watch this current slide, we have 4 diagrams of 4 different types of electric vehicles. We have what we call the battery electric vehicle. That car has only the motor, controller, and battery, nothing else. Then we have the plug-in and the hybrid. Now, those two are in the middle. These two ones are all hybrids, but different types. Okay? They all have both an electric motor and an internal combustion engine. But the size of their batteries are different. For the hybrid, you will not see any plug apart from the plug for the petrol on it. And the batteries it has is quite small. So what it does is that as the car is moving, you go to the petrol station, buy the petrol, you fill the car, you start driving it. As you are driving the car, it will use using some of the energy from the engine to charge the battery of your car. At some point, when the battery is sufficiently charged, what it will do is it will shut down the engine and now turn on the electric motor. So if you have driven in this or driven one of these cars before, you see that when the engine is on, you can hear the sound, the vibration. Then at some point, if you switch the motor, silence, you are just crazy. The beauty of it is that it is more fuel efficient compared to the normal petrol car. When you buy 1 gallon and normally you use it for 100 kilometers, with the hybrid, you may go 120 or 130 or 150. The plug-in hybrid is similar to the hybrid. However, the plug-in hybrid has a bigger battery than hybrid. So therefore, you will see these cars having 2 plugs, one for petrol and one for their charger. And unlike the hybrid, that you cannot use without having fuel, you can decide to use the plug-in without any fuel at all, because you just go and plug it directly into your wall socket in your house or the charging station. Charge it when you have a full charge, can be moving around. There are a number of considerations with these hybrids, be it normal hybrid or plug-in hybrid. Number one, their electric range tends to be shorter than their range for the normal engine. Very, very key. And the hybrid's range is shorter, electric range is shorter than the plug-in. Secondly, and very concerning, is that with the hybrids, you have now multiple points of failure. Think about it. You have the electric motor, which can potentially fail. You also have the internal combustion engine, which can also potentially fail. And all these two have their supporting system. And the internal combustion engine, once it's there, is burning fuel, so it needs exhaust. It needs all manner of things. The electric part also needs a controller and all manner of things to support it. Then, because they have to work together, there is a point of interconnection. That one too is also a point of failure. So, depending on the engineering that goes into it, hybrids can give you more problems. Then we have the last type, which is the fuel cell. These are the so-called hydrogen vehicles. They are also electric vehicles, but this time around, instead of charging or getting the current from an external source, they use catalytic processes like maybe breaking down water or getting hydrogen directly into it as a source of energy for their current, which is then used to power the vehicle. Now, the picture before you is a picture drawn to scale of two engines, an internal combustion engine and an electric motor. Now, what is interesting is that the two of them can give you the same power. So let's say 400 horsepower. The motor can give you 400 horsepower, and the engine can also give you 400 horsepower. Now, when you look at this picture, it explains why the electric motor is superior to the internal combustion engine as a source of transport power. It is much, much, much smaller. You can see. It is less complicated. There's no fan belt. There are less moving parts, so no need for this engine oil. The things that give people wahala, spark plug, all those things. Gone. You don't need a transmission because all of us know that every car, the engine is either in the bonnet or in the boot. But with the electric motor, look at the size of it. Because it's much, much smaller. People can put the electric motor on directly on the axle of the car. That is the bar that connects the two tires. So the front tires will have one, the back tires will also have one. You can put the motor directly on that. So you don't need the transmission, depending on what you are looking for. Sometimes some people put even the motor within the wheel of the tire itself. So like Rivian likes to put their motor in the tire. So each tire will have its own motor. That is 4 engines in each tire. This can give interesting results. Where, for example, they have this they call the tank where the car can stand at one place and turn 360 at one place. Or you can see the car move sideways without turning. All manner of things. So this chart alone, for this section of the talk, If you don't get anything, please get this chart. It answers every question. If I were to make the electric motor as big as the internal combustion engine, I will get 3 times the power. And now another very important thing, the electric motor is more efficient. In other words, if I give the two of them the same amount of energy, the electric motor will give me 4 times the motion as compared to the internal combustion engine. Why? The internal combustion engine has to burn the fuel. It will waste some of the fuel in the form of heat. You will hear noise. That is energy. It is waste. You will hear vibrations. That is waste. So efficiently, the internal combustion engine can get around 25%. But the electric motor, you can get between 90 to 95% efficiency. So less output, so more output for the same input. Now, how does this translate into, let's say, this efficiency? How does it translate into driving? So this chart you are seeing, I have a number of countries that from those of us on the call, from some of the countries, I picked some data for some of those countries. This is Ethiopia. If you notice, Ethiopia has gone aggressively EV. They're the first country in the world to ban sale of all brand new vehicles today. The yellow charts are all electric vehicles. See how much cheaper it is to fuel their cars if they are electric, as opposed to buying petrol and diesel. And this petrol and diesel, they have to import it using hard currency, sending money to people out somewhere in Europe or China or India or America. But the electric, they have their hydroelectric power, very cheap. It's a no-brainer. The question then becomes, are the cars available and are they affordable? And can they readily get access to them? The same chart for Kenya. As you can see, Kenya, the difference is still there, but it's not as stark as compared to Ethiopia. But it's cheaper to drive electric in Kenya. And these are various cars. Some are the mini cars, some are pickups, some are the normal passenger vehicles. And the same for my country, that's Ghana. It's cheaper to drive electric in Ghana. And I made the chart in dollars for the sake of a sense of comparison. Huh? This is Zambia. The Zambian ladies. Of course, Sierra Leone. And then we have Liberia, Senegal. Okay, my time is almost up. Now, the chart I showed you previously are based on fuel prices. So at the time the charts were created, these are the prices of petrol, diesel, and electricity. I will say though that this chart, there's a need to be cautious because whilst the petrol and diesel are in liters per liter, that's the price for 1 liter, the electricity is in kilowatt hours. So it's not a direct comparison. It's supposed to give you a sense. You can compare the price of petrol and diesel for the various countries directly, but you cannot compare for that country. Let's say we take Ghana, the price of petrol and diesel to that of electricity. It should be a false comparison. All right. Now, the other question is, if you're talking about electricity, how readily available is that electricity? And this chart addresses that. As you can see, there are large segment of our population without access to electricity. Number one. And number two, another thing you notice is that most of the people with access to electricity are in the city. So that suggests that electric vehicle adoption normally should start first in the cities before it spreads to the rural communities. This is the same chart, but in terms of per capita. That is with consideration to the population of the people. Now, there is a difference between electric vehicles and petrol vehicles in terms of how we use them. Same as there's a difference between how we use smartphones and how we use the feature phones. When you are driving your petrol and diesel car and you step out of your house, your first point of call is the fuel station because there's hardly if anybody who keeps petrol or diesel in their houses, unless it's meant for your generator. But with electric vehicles, most people, by and large, they're in the cities, have electricity at home. And 80% of the time, people are either charging in their houses or they do what we call destination charging. In other words, they're coming to the office. When you come to the office, you charge in the office. They're going to the mall. You get to the mall, you charge at the mall. Or you are going to a hotel. When you get to the hotel, you charge over there. And when I say charge, don't have an idea of a highfalutin thing. You can charge with a normal socket in the house. It may be slower, but you still charge. Okay. That also means that if you are somebody who has a fuel station, maybe you need 10 fuel stations. For an electric charging station, you may need less because people are not dependent solely on you for charging. They have alternatives. Now, the chart you saw earlier about the electric motor and then the internal combustion engine, this is how it translates into maintenance. When you see the electric vehicle, you still do maintenance. You change tires, mainly. Maybe your shock absorbers may get spot, but a large chunk of things that you have to change with the internal combustion engine it's not necessary. You don't need to do regular maintenance every quarter. So if you are somebody who is into, let's say, car sales, you have a dealership or you are into maintenance, and most of your money comes from the quarterly maintenance. Every quarter, the customer has to come and do engine oil change, whatever. That revenue will go away when you go to electric. So these are some of the benefits of having a station like this, where you now begin to think about alternatives. Because whilst this thing is destroying your business model, your current business model, it's also creating opportunities for new and sometimes more lucrative business models, where you can make maybe even more money. All right. Now, in terms of performance, the electric vehicle beats the internal combustion engine in terms of performance. The problem when it comes to the electric vehicle for a long time has been with the energy storage system. So I show you that the electric vehicle came before the internal combustion engine. At the time, this internal combustion engine was noisy. It produces smoke. It vibrates. So ladies prefer the electric vehicle. You know, you have influence. The problem was that this electric vehicle have very short range. You can drive them 5 kilometers, 10 kilometers, 20 kilometers. For the internal combustion engine cars, you can, even though they are noisy and smelly, you can drive them 100 kilometers, 150, 200 kilometers. So when this Thomas Kettering guy figured out this starter, where you don't have to use manpower, nonetheless, can even drive this car, just park it. It was one of the death knells of the mass adoption of the internal combustion engine vehicle, but of the electric vehicle, because, like I said earlier, the transportation problem is also an energy problem. Now, if you are deploying an electric vehicle, at the time, electricity was not common. You're not coming to set up all these grid infrastructure, transmission lines, power stations, transformers, all these kind of things. You have to spend a lot of money to build roads for these cars to drive on, and also to build the electricity infrastructure for these cars to charge. Or if we are going with the petrol and diesel cars, we also have to spend a similar amount to build charging stations. Henry Ford was a fellow who made the car, the mass production of the cars possible, and thereby reducing the cost. And he was the one who was forced to make that decision, whether to go with the electric or to go with the internal combustion engine vehicle. And the rest was history. He chose the internal combustion engine vehicle. Why? One of the reasons was because Rockefeller of Standard Oil was ready to build all the charging stations necessary to fuel his car. So Ford doesn't have to look for the money to build the charging stations themselves. Like you saw, or we all saw with Tesla, when they now decided to make these cars popular, they were forced to build their own charging stations. So that price, somebody still had to pay. And now that the cars are becoming popular, people are now ready to now invest in some of these charging stations as their own business. Okay. This is a chart comparing the range or how far these cars can travel. As you can see, with the improvement in battery technology, the ranges are now comparable. This chart is a bit old. The differentiation is less now. Then we have electric vehicles, some that can go 1,000 kilometers. So the range issue is a function largely of the past. And it boils down to you, as a consumer, your purchasing decision. Now, for a long time, electric vehicles were higher, had a higher price tag than a combustion engine vehicle. Mainly because, once more, of the batteries. The batteries are the most expensive part of the electric vehicle. So if you're on this call and you work in the insurance industry, for example, when assessing the risk for an electric vehicle that you want to insure, the most significant part of that risk will be coming from the batteries. Are the batteries under warranty? Are they, what is the state of health of the batteries? What's the usage level? Are they air cooled? Are they water cooled? These are some of the questions that you need to ask and get answers for in order to properly assess the risk and therefore calculate the right premium for the person. Otherwise, you'll be forced to do what a lot of insurance companies are doing today, which is they call a price according to their feelings and hope and pray that nothing happens. So you either end up overcharging the clients or undercharging the clients. It's not a tenable business in the long term. With the advancement of technology, what is of interest now for a long time is price parity. How aligned are the prices of these cars with our normal petrol and diesel cars. And if you remember the chart I showed you earlier about the various segment of the auto sector, we are getting price parity starting from the micro mobility segment as we go, and also from the top down. So let's say you look at luxury cars. Luxury cars now, compared to electric vehicles, have price parity, and in some cases, the electric vehicle is even cheaper than its internal combustion engine sibling. All right. I think my time is up. Yes, so I will end here. The third part of the presentation I cannot talk about it for now, but I'll make the slides available for you. Thank you very much. Faith?
Thank you, Gad. Liri, that was a very great session. You can see the ladies are appreciating you. A little bit of some of the participants saying they could not hear you, others saying they could not see the screen, but we maintained over 115 participants throughout the session, which was a great thing. At one point, we were at 126 participants in the sessions listening. And I really appreciate the ladies for really making time to be here because that is the only way they would be able to learn. So I wanted to share some of the questions, the ones I can see. Are there any solar carports in Africa? The other question is, are all batteries the same size in all EV cars? The third question, are the charging infrastructure standardized in the world? The other question, what if the petrol stations...
Let me take one by one. I had a question about... the first question was what?
Yeah, we have one more. You want me to read it?
Yes, please, but start with the first one. I lost track of the question.
Okay. Let me go back. Let me read the first one, then you can answer each. Are there any solar carports in Africa?
Solar what?
Solar carports in Africa. Are there any solar carports? Yes.
Okay.
Yeah, we can hear you. Proceed.
Oh, okay. Solar carports. There are some people attempting that. The problem with solar is excuse me, is that is the quantity of energy you can get for a given surface area that is sufficient to power an electric vehicle. You know, a car is very heavy, so the size of batteries you need and the capacity of those batteries is quite big. Literally, in some instances, one car's battery can be 10,000 times bigger than the battery in your cell phone. Okay, that's one of the reasons why electric vehicles are the ones driving a lot of technology improvements in these batteries. So, for you to get a solar powered charging station that can power a car directly, it's a long time thing. And it will take a long time to do that. What most people rather try to do is to have a battery at that charging station, then use the solar panel to eventually charge that battery so that when the car comes, that's transferring fast to the car. There was a question about are all electric vehicles have the same size of battery? No, please. No, please. And that's what affects the range of the car. You see, just like all the normal petrol cars don't have the same engine, tank size. Some cars have smaller tanks, some have bigger tanks. The same for the electric vehicle. And the tank of the electric vehicle is a battery. The battery is just a container for electrical energy. That's all that it is. The equivalent for the internal combustion engine is a fuel tank. The only difference is that the electricity is, you're talking about electrons, but for the fuel tank, you're talking about atoms. You actually hold it. What was the other question? There were some other questions I missed.
I have two hands lifted up, John and Mary. I don't know, maybe they wanted to
Okay.
ask a question.
John
John,
is
you could
here.
go ahead. John Musingo is here. John, welcome.
Hi everyone. I am not a lady, but I think I'll be taking you guys on the course for charging. I just wanted to weigh in on the issue of the carport. Whenever a solar project is done, it is almost entirely very difficult to find a solar project being able to fully power a building. I'll give an example. If you'll find that malls might have, your typical mall would have something like an electricity bill of about $100,000. What happens whenever it is that you put the solar is that solar typically will account for 20 to 30%. That means that if your bill is $100,000, you'll be able to save between $20,000 to $30,000 a month. And it now comes down to aspect of finance. Does it make sense then to go for the capital outlay for the solar as opposed to powering it directly from the grid? That's number one. Number two, when you look at the chargers, as God has said, draw a lot of energy. This energy to be able to power, so a typical charger level 2 would be about 7 kilowatts. You would need an extremely big array of solar and batteries for you to be able to just power that charger. We're not saying that it is not possible. It is possible, but we're looking at the economics of it. Is it worthwhile? So that's the difference. Thank you.
Thank you, John, for that insightful thought process. I wanted to share the other questions. Gad, I hope you're ready.
Yes, please. I'm ready.
Okay. Can
Hello,
solar
Faith.
power?
Sorry. Before you go into another question, I wanted to shed more light on the solar powering a vehicle. So I don't know if I can go ahead.
Yes, Toru, welcome. I didn't know you're here. Welcome. Please go ahead. Karibu.
I came in silently. Yeah. So basically, of a car, it's limited in size, and to have an amount of energy with solar panel, you need a considerable number of size that can give you that power, which the surface of the vehicle doesn't usually have. Then the issue of aesthetics also coming. Even if you make the body of a car solar cells, PV cells, like Tesla is making solar roof, it will still not give you the amount of energy that you need. However, there has been argument that because cars are parked 70% of their lifetime and they are only on the road for the remaining 25-30%, that whatever amount of energy you can, move from the sun and put in is also good. But at the end of the day, you can get more than 1 to 10% of energy from it. So you will see that the cost benefit is not even there. Then the aesthetic issue is not reasonable. And there's no way you can power your battery, your car directly without the battery because of the amount of current that you require. So this is one of the reasons why it is mostly reasonable to use a BEV, what we call battery electric vehicle, and make sure. However, there are trucks that have solar panels on them, and they are mostly used for cooling system, which means that once those trucks are parked, you can easily get some energy for cooling, not necessarily for moving the vehicle and a whole lot of that. So there are different use cases because a truck has a lot of surface area, but it doesn't mean that the solar panels are the one moving the vehicle. I hope that helps. Thank you.
Sure, that helps, really helps. Jochen is here. He has joined us. Welcome to the platform, sir. You are very welcome among these
Thank you so much.
ladies. Yes,
Can
yes,
you
we
hear me
are
already?
doing. Yes, we can hear you. Some questions that we are taking, Gad has already taken us through the session. Some questions, I am reading out what the ladies have shared as questions. Can solar power be used interchangeably with electricity, especially in regions experiencing large solar energies? Can solar power be used interchangeably with electricity, especially in regions experiencing large solar energies?
I think that I will let Olukoku answer that. Then we can let Jochen. We can start with Jochen, and then we can bond the rest of the question at the end of Johen's. To add it to the Q&A there. I think that may be wiser for the sake of time. What do you think?
Yeah, I think the best thing, maybe we consolidate all the questions. Then looking at the time, then we can be able to share them for answering by all the speakers who are in the platform. They can take turns to answer each.
Okay.
Thank you.
Okay. Do you still want to answer for the last question?
Yes, Toru.
I don't know in which context this question is coming from, whether you can use solar or the grid. If it's for charging and charging at home, right? You majorly need to know the kind of matching electricity you are putting in your vehicle. So if you are doing a DC-DC charging, then you want to do that directly from the solar PV, you have to match the requirements, like the voltage requirement as well as the current requirements. So, but then if it's generally saying, okay, I have solar system and I have an inverter system and I'm also connected to the grid, whatever supplies your home and you are charging the vehicle will take it. But the amount of power available determines the rate of charge, whether it's slow or it's faster. But if you go to a commercial charging, majorly you don't want to bother yourself with the source of power. It's either you are doing a DC-DC or you are doing AC to DC. So far you get your vehicle charge and and you pay for your service, you might not relatively care about the source of energy. But if it's for home and you are trying to put some power into your vehicle, well, your source also determine, and also matching the requirement for charging is really important. I don't know if that answered the question, except I get more context of switching from solar to grid and all of that.
That is maybe something where I can speak already from experience. I don't know. Shall I maybe introduce myself before answering the question, or what was the plan?
Please go ahead.
Yeah, great, super. So thanks to Gert, I'm here following the invite. I'm really excited to speak to you guys. Maybe a bit about my background before I answer the solar question. So I'm an automotive executive. I worked over 25 years in the industry. I'm born in Germany. So as a German engineer, you want to work with BMW or with Porsche. I did both. I worked for both company, and I was actually, and I'm still excited for their brands and their products, no doubt. But I was actually also a bit bored because those big corporations, for some people like me who have more an entrepreneurial startup mindset, they can be boring. And in that light, in 2008, I was on a conference. I saw a young Elon Musk speaking about electric cars, and I thought, oh wow, how crazy is that? I somehow need to follow. And I did my research. I checked everything about this gentleman, who obviously sold his company to PayPal, right? And made a fortune with that. And before had also successful exits. I was really fascinated. And then I thought, like, let me study a bit more the electric car. And I was really fascinated about how clear it is and possible it is. And there was only one thing where I had personally questions, which was the battery price back in the days in 2008, 2009. You have to know, in 2008, the kilowatt hour was super expensive, was $1,300 per kilowatt hour. So a battery pack for a normal car, that was $60,000, $70,000. And then if you add the car around the battery, you're landing at $100,000, right? So far, far, far away from mass production. And I thought, I'm lacking the experience. Let me simply call Tesla and ask that question. And I found myself in a conversation with a young Elon Musk in 2008, who told me, Jochen, don't worry. Tesla, we will build gigafactories. We will produce batteries in the high millions. And what happens is Moore's law kicks in, the economics of scale kick in, and the battery price comes significantly down. From there, I thought, like, okay, this guy has a plan. He talked about battery prices for $100 and below per kilowatt hour. This is exactly what we now see 2023. I think it was reached the first time, which was exciting for me. And obviously back in the days, then I joined. So long story short, I joined Tesla. I was 10 years in the company. I was also a direct report of Elon Musk. I was more on the operational side. That means I was running sales teams, marketing teams, after sales teams. But not only that, and particularly in Europe, but I also helped and I led the turnaround in China back in the days. I was responsible for bringing the gigafactory over to Berlin and Germany. Obviously, I had high interest running this market to also get the to get a gigafactory over. So I was not just selling with my team cars. There was a lot of work behind that. We met governments. We influenced EV incentives, subsidies for end consumers, for fleet owners to go electric, convert their cars electric. We delivered thousands, 10,000s of test drives with my team, which grow. I was a one-man show at the beginning, and later on, when I left, I had 300 people in my team. Yeah, I built basically the operations around that in European markets. I started with small ones, then big ones, and eventually I led the whole region.
What is your problem?
Reported to Elon. So I then in 2019 after 10 years I left Tesla. I became a chief at Automobili Pininfarina. That's a electric hypercar maker. And it became a bit boring for me because you just sell one car before you save the planet with thousands of cars. And from there, I decided to do what I can do best, which is what I'm doing now. I'm in the board, advisory board, and an executive consultant for different, mostly electric car companies, and same time running my own projects with different teams. For example, on that front, together with GAT, we're spending time on how can we further electrify and build fast charging stations in Africa. Be the first domino stone, so to speak, because obviously it's always a chicken and egg problem, right? The government says, yes, we want to drive electric cars, but we need fast charging stations. The guys who are doing fast charging stations, they say typically, well, there are no electric cars. For whom are we building fast charging stations? So it's hen and egg, as we call it. And hence, my experience with Tesla is best is you do both, right? So we want to convince the governments to go in with both at the same time to really have like a faster and larger EV adoption. That's it about me. For like a 5-minute summary, I'm happy to talk more about that. Now to the solar question, and I can answer that from own experience here. Right now, I'm living between Saudi Arabia, London, and Germany, and in our house here in Germany, we have 2 electric cars. We have not only that, it's a wooden house, by the way. You see maybe a bit the ceiling here. So very sustainable materials and so on. But it was very important for me from the beginning to charge the electric car with solar, because only then it makes sense. It fits only then together, right? Really, if you avoid carbon emissions, it doesn't make sense if you burn. I mean, it is even better and more efficient if you burn oil for generating electricity, because the electric motor is so efficient. But the better and the best story is obviously to charge your electric car from renewable energies. So we have a 10 kilowatt peak solar panels on the roof. We have a so-called home storage system that's a bit smaller. It's 10 kilowatt hours. And what we typically do on a summer day, you plug in your car. The wall box is smart. When the solar panels generate electricity, the system knows exactly how much energy needs to go into the house, for the oven, for the television, for electricity in general, house consumption, or for charging the cars. From own experience, I know that with the 10 kilowatt peak on a normal house roof, this is basically enough to charge more than what you daily commute, what you daily drive. If you drive, an average German drives 50, 100 kilometers a day, that is by far something you can charge from the sun energy you're generating on a daily basis. So this is something which works out quite nicely. It decentralizes you from the normal grid and the normal electricity packages from your utilities. And hence gives you also this good feeling that you're generating your own electricity for your own electric car and for your own commute, which is, for me personally, fascinating. Yeah. And I think back to the moderator, I guess there are more questions around EV ownership and using electric cars in daily life, or how should we structure that?
Yeah, I think that, sorry if it's, let me jump in a bit. It would be best for you to tell us your ownership journey and some of the things that, what were your expectations, what surprised you, what disappointed you, because you have the unique perspective of being an owner as well as a producer and a seller of these electric vehicles. So you can address those. That would give us and the ladies context. Then they cannot come in because I'm sure they have a lot of questions about the ownership experience, practically how to live with it.
How to live with an electric car? That's a very nice question.
No.
And that
Good.
And that goes back, and that goes actually back. Obviously, as a Tesla employee, you start driving electric very early on. That was the first time. It was in 2008 then, or 2008, 2009, when I met the Tesla team there. But in 2000, as of 2009, I got my first test drive car for Tesla to build the Swiss market. I was living back in the days in Switzerland. And obviously from there, it was a very early EV experience I made, which came with charging at normal plugs. Okay. And what I mean with this is basically I was living in an apartment, and in my underground garage, there was no wall box. There was also not an easy supplier network of wall box because the whole industry was new. We're just establishing it, right? So basically what we did, we sold the Teslas with a normal charger for the normal plug. Yeah, like what we have here, the Schuko plug, you know, and also the three-phase red plugs or blue plugs. And I simply charged on a daily basis overnight at the Schuko plug. That is around 3 to 4 kilowatt per hour. So 10 hours sleep, or when you're 10 hours at home overnight and whatnot with breakfast, you know, it gives you 30 to 40 kilowatt hours. A typical battery today has maybe 50, 60, 70 kilowatt hours. Large ones from Tesla or Lucid, they have 100 kilowatt hours. So in that context, in comparison to a large battery pack, it gives you maybe a third, you know, maybe half what the whole battery could take. And my experience is this is by far, far, far enough for your daily commutes. If you go from home to sport, to the supermarket, you know, to work, you know, you commute on a day, maybe 50, maybe 100 kilometers. Electric cars today, they're so efficient. They consume around 15 to 20 kilowatt hours, 15 to 20 kilowatt hours, depending on driving style and so on. So if you charge 30 to 40, you know, you can drive on a daily basis 200 kilometers, you know, without any special installation. So obviously, not everyone should simply plug in one house, you know, and use the normal sockets. Why? Because the normal sockets are not made for a continuous, long, high power electricity consumption, like from an electric car. They basically would go high power for a very long time. That generates a lot of heat, and obviously on the long run is not the safest way to charge cars. Hence the whole industry got established, which is AC wall boxes, 11, 22 kilowatt hours, and that is the way forward to install it now. So maybe that was my test drive experience with Tesla. I didn't own a car then, and then in 2013, when my first daughter was born, it was the first time when I also decided to buy my first electric car. Obviously a Tesla, that was a Model S, a used one. And I bought it for a few reasons. First reason was I decided I want to drive the safest car in the world with my family, with my young family, because a lot of people, they oversee that, or they think that the combustion engine in an ICE car, in an internal combustion engine car, is protecting you, but actually it's the opposite. If you have a front crash, then your combustion motor, your combustion engine is pushed into the inside of the car, and hence causes heavy injuries for the driver and the front passenger, particularly in the leg, knee, hips room area, right? So it's by no means a buffer. What is really a buffer is when there is nothing at all, like in an electric Tesla Model S. You know, you have storage in front of the car, and they have built the structure of the front hood in a way where it is a much larger grumble zone. So it's much more safe. This was a very important driver for me, why I said, hey, now with the family, I rather spend a bit more in that time, but I want to drive the world's safest car. That was the Tesla. And obviously then also my kids, they will likely see the year 2100. And I thought somehow you need to contribute that this 2100 is a really nice, that the world, the planet, the Earth is still in a really nice shape, and I wanted to contribute that for my kids. So that's why we bought an electric car. But the challenge I had back in the days in Switzerland was we lived in an apartment, and the switch box was not next to my car parking, my parking slot, right? So I would have needed to put a very long cable to the switch box. So what I decided is to basically charge also when I owned my very first electric car on the normal plug, like what I mentioned before, the 3.5, 3.7 kilowatts with the 30-40 kilowatt hours per day. And again, that was by far enough for my normal commutes. Tesla, and this is what I love about Tesla, Tesla as the innovator, they came and still come into the markets, not only by offering cars and selling cars, also by building the network. You know, there is no EV adoption I've seen worldwide without both a fast charging network and the cars. So I could totally depend on that setup, meaning a bit charging on a plug at home, and then whenever we drove long distances, we had Tesla's fast charging network. That is absolutely no problem. Fast forward today obviously I have a wall box installed with 11 kilowatt, so that gives you per hour 11 kilowatt hours. Or if your battery is completely down, then overnight you can fully charge the car, like the 100 kilowatt hours, without any problems. And obviously today Tesla has many more superchargers installed. So I regularly, you know, in vacations, we go to Italy or France or so on. We drive 1,500 kilometers. Every 400 kilometers, we anyways need a break. Why? Because the kids or myself, we are hungry, or we have to have a bio break, you know, or you're simply tired after driving 1,000 kilometers. And that is the best opportunity to charge in parallel while you know, enjoy the break, have lunch, dinner, and then continue your ride after 30 or 40 kilometers. In the beginning of my EV ownership, everything was new. Obviously, when you talk to the electrician, my experience was you had to educate them because they didn't know anything about electric cars. This is when you know, Tesla was really well equipped with all the documentation, how to install charging stations, and documenting also the car, what it does and what it needs. The same goes for obviously registering the car, for insuring the car. Hardly any insurance company know exactly what they exactly insure. So this needed a bit more effort at the beginning, but once you have found this one insurance, then obviously it's really a great and easy thing to register electric cars also at the beginning. The fact that you don't have an oil change, you don't need to maintain your combustion engine motor, you don't have to change filters, etc. That makes it much easier when it comes to service. In fact, companies like Tesla and others, they partly only recommend you to do service, but you don't need to do it for warranty reasons or so. So with my Teslas, not seldom, I'm changing my tires because of seasonality, right? Summer tires to winter tires in winter. I don't have to do that with a Tesla service center. I can just go to a tire station. But for maintenance or car service, there's not much to do. The wishing water at home, I fill up myself, for example. The car gets regularly software updates. So on nearly weekly, bi-weekly base, I get software updates, partly with bug fixes, but also new functionalities. I remember a Christmas gift, for example, from Elon to his owners, when Tesla, the engineering team, learned how to pull out the maximum power and torque of the electric motors. They pushed this software update to the cars, and suddenly my car accelerated faster. Simply by a software update for free. There was no payment for me I had to make. So that's a very positive effect, because obviously as soon as a combustion engine car is coming from the factory, it is already old, because typically the car manufacturer is working on the next generation, on the next model year. But with Tesla, there was a lot of thinking, let's leverage the great product they have and considering more as a PC, as a computer, which gets better with software updates and so on. I also remember an experience in the early years, a so-called hill holder. If you were on a slope and you were driving forward, then you would roll back, right? And Tesla invented an electric hill holder. So whenever there was a slope detected by the Tesla, the electric brake started, and only when you pushed forward, you would drive. That was also a software upgrade, for example, and free of charge for customers, which is really fascinating. Another time we got an update which affected, or was after the so-called vampire train. The vampire train, what is it? Obviously, you have a computer here. Obviously, you have a lot of electric components here, and they all pull a little bit electricity, a little bit energy overnight when the car is standing still. And this can be, 0.3, 0.5 percentage points. But if you're not managing it right way, then it might be 2, 3, 4%, right? And at the beginning, Tesla had also to learn. So they developed a software update which steered the this vampire train down. So after installing that, the vampire train was much lower. Hence, your range was better suddenly. All this kind of things, by considering the car more as a computer than a car which is built, finished, and the manufacturer is working on the next model year already. That gave me a really pleasant, a really good customer experience and ownership experience, because my car actually got better over time, had new functionalities over time, was faster over time, and so on and so on. And obviously, also from a maintenance perspective, only as it's recommended, I save a lot of money. The electric car is much cheaper to maintain. I touched on it. No oil change, for example. You don't have all these expensive parts you need sooner or later to replace, like a clutch, for example, or a gearbox. There's no gearbox. the electric motor is so powerful, you can just have one gear. And where there are less parts, you have less service costs, for example. You know, so yes, you might pay a bit more maybe for an electric car, but still the parity is very close. Some countries reached it already. But on the long run, the electric car gives you the better experience and also typically the cheaper experience. So what I would always recommend is not just comparing the purchase price of a combustion engine car or an electric car, but compare it with 5 years, 6 years, 7 years of usage, right? When you have to put in all the costs for petrol, gasoline, all the costs for service, oil changes, clutches, and all the parts which get destroyed. And obviously, on the long run, then typically it gets much, much cheaper, which is a very positive surprise, next to the fact that it's also getting better usually over time as it's perceived as a computer. I've seen there isn't on the chat, there are a lot of questions. Shall we cover a couple of those? Maybe the first one was, how is it safe of batteries considering they use lithium-ion batteries, which doesn't go well with a lot of heat? So very good question. Thank you for that, Leah. Obviously, batteries, they come in battery packs and with different technologies. So in today's world, you have nickel mangan batteries, you have LFP batteries, lithium phosphate batteries, iron batteries, you have cylindrical cells, you have pouch cells, you know, you have prismatic cells. So it's a very detailed answer I could give you on that one, but let me simplify it to that. Obviously, batteries get hot when you pull out energy, but the industry mastered it already with water cooling systems and the right approach and the right cell chemistry. So it becomes not an issue for EV owners typically. If you want a very, very exciting solution, then I would recommend to you to check out YouTube and the Cybertruck video when Munro Associates, Munro, they're fantastic engineers. I think when it comes to electric, one of the world leaders. They typically buy the very first cars of new car announcements, and then they do a tear down. Basically, they buy a car and then they take it apart. They have done that with the Cybertruck, and they have found even a technology which avoids that a battery could burn, you know, by simply monitoring not each module, but also each cell. And when a cell is behaving abnormal, as they call it, you know, a module will be taken down and isolated. So there are fantastic technologies around that. So that would be the first question answered. So the second question is, how much does the battery pack weigh? How does the weight of the battery pack affect the vehicle handling performance? Very good question. Thank you so much for that, Lenatis. So I would say also here on the weight, there's new technologies, and but typically you can say a battery pack, depending on the size, can go from a 450 to 650 kilogram. So it's a massive part of the car. Obviously, if you buy a car with a 60, 70 kilowatt hours package or 100 kilowatt, it makes a difference of 30, 40% already. That goes 1-to-1 linear to the weight. How does the weight affect the handling performance and overall efficiency? So the great thing is that battery packs typically are underneath the car. It's a skateboard structure. Today, the latest technology is even that the battery becomes a structural part. So you save weight from the chassis, and hence it becomes a part which gives the car rigidity, right? And given it's under the car, it gives you a fantastic low center of gravity. And then given it's evenly spread out over the whole platform, gives you a 50-50 weight distribution, which is the world best weight distribution you can have. Porsche 911s, they are nearly 50-50. They have, I think, 51-49, something like that. But this is really, really something you want, 50-50. Because like that, you don't have, you know, if you have like too much weight in the back, then your car goes up. If you drive in a corner too fast, then you oversteer because all the weight is in the back, right? If you have too much weight on the front, you know, there's the reverse effect. If you go uphill, that the wheels are turning. So 50-50 is the back, is the best, and this gives you exactly the great handling and capabilities. It feels a bit to me, driving an electric car, like being with a car on rails, given that great weight distribution. Performance-wise, much more fun, much more fun. I told you before, I bought the car for, you know, safety reasons and for saving the planet, but also for fun a bit. Why? Because the electric motor has the maximum torque from the start. And the combustion engine always needs 2,000, 3,000, 4,000 revolutions. Think about all the videos you have seen for Ferraris and Porsches. They're all getting loud. You know, all this shifting is needed because you need the revolutions to generate all this power in a combustion engine car. But with an electric car, you have immediate, on an electric motor, you have immediately the maximum power and the torque from the start. So there's no delay, there's no lag. You have really great sprint values. You know, going from 0 to 60 miles per hour to 100 kilometers per hour. Typically, electric cars are much better. You can put an electric smart, you know, the two-seater, you know, 15, 20,000 euro car next to a Porsche 911. The first 30, 40 meters, the smart is much faster because of the power is there, and the Porsche needs the revolutions. Obviously, overall efficiency, much better in electric car. The electric motor has 90 to 95 efficiency degree. We are always joking about combustion engines. A combustion engine is more a heating, which happens to also move you forward. Why? Because the efficiency is so bad. Efficiency degree is like more 30-40%. The rest is heat. While, as mentioned, with the electric motor, it's 90 to 95%. Much better. That's why the motor is also so small. All the energy you put in can immediately be used and leveraged. Next question from Catherine Citati. Thank you for that. What is the technology in extending the life of the battery pack? It is not a risk process. So let's talk about battery life. The battery life of a battery is so good that the electric car companies today already give warranty for 8 years, typically. Some without any limitations, mileage limitations, other with maybe 200,000, 300,000, 400,000 kilometers limitation. But the life of a battery is already really good. Yeah. And then after that 8 years, when you run out of the warranty, it doesn't mean that you have to throw away the battery, but the capacity is maybe more towards 70, 80%, not the 100%. So if you can drive maybe with a battery pack, let's be simple for calculation reasons, today 1,000 kilometers, then maybe in 8 years it's 700-800 kilometers, just to be a simple calculation, simple math. So there's not so much worry about the life in general, but if you want to support and have a longevity of your battery pack, then the charging, how you charge your battery is important on the long run. There are studies, if you charge your car 5, 8, 10 years, more times with a normal plug or a wall box like 11, 22 kilowatt, that is supportive of a long battery life. If you, however, for 10 years in a row, always go fast charge, 5 Minuten, 10 Minuten. Yeah. Sorry, I got interrupted here. Little home office challenge. So if you fast charge for 10 years only your electric car, then the battery degradation, as we call it, you know, the dendrites which are building in a battery, they're destroying battery life. So it's not that good on a long run. But typically what you have across the world, I was building markets in Europe, in the US, China, and so on. I have seen always a comparable pattern, usage pattern, where EV owners, they 70–80% of the time they charge at home, slow charge, which is good for battery life, and then maybe 20–30% on the road fast charging when they go long distance for business or for vacation, for example. Next question from Amina. In what ways can electric vehicle technology be adapted for use in commercial and industrial applications such as heavy duty trucks, buses, construction? Hey, I love this question, Amina. Thank you so much for that. If you ask me, sooner or later, everything which moves will be electrified. Everything which moves will be electrified. It starts with the easier cases. It starts with the low-hanging fruits, as we call it. Wherever you can build charging stations, it's much simpler, obviously, right? So I'm talking about passenger cars. You want to avoid, you know, noise in city centers. You want to avoid exhaust in the city centers, smoke in the city centers, you know, carbon emissions, carbon monoxide. That's why electric passenger cars, you know, are a clear path forward. But with buses, particularly the city buses, you know, which go on a daily basis in their routes, very plannable. You know exactly the stops. You know exactly how long it takes. You know exactly the energy needs. Clear path forward. China deployed 100,000 of electric buses already. India just made an announcement this year. They want to deploy 800,000 electric buses, for example. Very clear, very straightforward. Then it gets a bit more diffuse with trucks. Why? Because some of the trucks, they go 1,500, 2,000, 3,000 kilometers. And obviously for trucks, you need larger batteries. Obviously for larger batteries, you need the so-called megawatt charging. You know, it's not 100, 200 kilowatt charging, it's 1,000 kilowatt charging, for example. And that has implications on the grid. So I would say the ecosystem for that is a bit tougher to build than for the other two use cases where you simply install, you know, at home for passenger cars, your wall box, you know, or as me at the beginning, when you charge with your socket, right? But there are also a lot of companies building electric trucks. There is no big company I'm aware of without an electric truck program. Take Scania, take MAN, take Volvo trucks, Renault trucks. They have all electric trucks already. So they're all investing in that already. There are a couple of conversations about hydrogen for buses. Hydrogen comes with a different energy efficiency. A lot of people forget you have to generate hydrogen. It's synthetic. It's not a primary resource. It's not somewhere you're digging it up and you have it. You have to generate it. And the process of generating costs energy. And when you have hydrogen, then you have to burn it in a fuel cell. That costs energy as well. And this whole process is much, much less energy efficient. In fact, if you take the energy for 1 day, you put it through solar in a battery electric car, let's say you can drive with that energy 100 kilometers. Through all the conversion with the same energy of sun, with a hydrogen car, you can drive maybe 30–35 kilometers. Yeah. So 3 hydrogen cars, you know, are needed for covering what you can do with 1 battery electric car. It's then a question about, you know, planes, for example, and ships. I think on the long run, there are opportunities there as well. What must happen? The energy density need to further improve. Why? Because you cannot build charging stations up in the air or on water, obviously, right? That's why maybe edge cases, use cases for hydrogen makes more sense in that part. But obviously not every plane flies across an Atlantic or an ocean, right? They're also like in-country commutes, you know? So I think it will start there. In fact, there are already electric planes, small planes, light planes, and hence it will slowly go into that industry as well. Next question. Okay. What are the measures Tesla as a company used to manage thermal runaway? Well, per definition, a battery is not exploding. A battery is comes with thermal runaway in terms of an event, an accident with a cell, for example. I would again come to what I said before. Watch this YouTube video, the Cybertruck Munro Associates, with their latest technology where they shut down a whole module to avoid that thermal runaway is affecting the whole battery pack. It is isolated and then there's no harm. Next question, how can fires resulting from be effectively handled given that the fires are of high temperature? I would go back to that answer I've just given. In a country like Nigeria, where electricity generation is a major problem, what are the possible alternatives there when it comes to charging of electric vehicle? Will the solar power be enough as a backup? I'm obviously not an expert of the different African countries, or in that case, Nigeria, when it comes to electricity generation. I think electric cars, they offer a unique opportunity also for Africa as a storage system. You know, you install solar power or wind energy or also hydro energy, water energy, and the car can serve as a storage as well. We call that here vehicle to grid systems, which in overcapacity phases, the car can take the energy. So it gives you a lot of possibilities to make the grids smart. But obviously, you first of all need the backbone. You first of all need the stable electricity systems. Go. Okay, next question. How do generative braking systems in electric vehicle contribute to energy efficiency and prolonged battery life, and how do they compare to traditional braking? Great question again from Amina. Thank you so much. So the question is about regenerative braking. First of all, what is regenerative braking? So you can put electricity on an electric motor, and then the motor drives you forward. Or if you turn an electric motor, as we all know, it creates energy, electricity. Regenerative braking is nothing else than taking this effect. Personally, I love it. Whenever I'm on the motorway, I'm driving, let's say 100 kilometers, for example, 100 kilometers, for example, per hour on the motorway, and then I know my exit is coming in 700, 800, 900 meters. Instead of braking, I just let the car roll, and then through the friction of the regenerative braking, I'm generating electricity. That's 600, 700 meters, and obviously the speed of the car goes down. City traffic, you know, there is a red traffic light. Instead of braking, you know, you simply let the car run out, you know, and then you generate electricity. So also in city drive, where combustion engines cars consume much more typically, because you have to shift between the 1 second and the third gear, you know, up and down. That costs more gasoline. But an electric car with the stop and go and the red traffic light, it generates electricity. So it's much better and much more efficient. And then obviously that gives you range back. it is not 20, 30, 40%, right? It is more like a smaller one-digit amount, percentage, but it is there, and it's a nice addition. The second effect is it saves also the brake pads. I mentioned before that an important part of the EV ownership is that you spend less money on oil changes and part replacements, and the brakes are one of those parts which are less used. Less usage means you don't have to replace it, and you save money from that, which is great. Let me continue. I think there are a couple of questions on heat and explosion and so on. I think I covered that. Degradation, we covered that. What is the safest percentage to recharge a battery? Yeah, what is a good question? What is the safest percentage to recharge a battery? So a battery doesn't like two states. One is completely depleted and then not immediately charged. That can have structural changes to the electrolyte, to the battery itself. So it takes battery life away. The second stage, which is not perfect, is like fully charged, and then the car is not used, because then you have the highest voltage. Voltage is affecting the degradation. Not like today, not tomorrow, but if you constantly do that, it has a long-term effect. So the best is to keep your car between 30, 70%, state of charge. That is what batteries like best. Like you would with your gasoline car. You have it at home. Maybe it's half filled, maybe it's 1/3 filled, or whatever. So this is a bit comparable on that side. What are the most significant safety concerns with EVs in the event of crash, and how are manufacturing? So first of all, I want to say, given what I discussed before, the crumble zone, which is much larger with an electric cars are in general much safer, right? Then the battery, which is underneath, adds a structural element. In fact, when we crash tested the Model S the first time, the side pole test, there's always a side pole test, a front and a back test. The side pole was destroyed because the battery pack is so rigid and destroyed the side pack. So you're in a very safe car, given crumble zone and given battery packs adds to that. So then obviously people are obviously discussing often the event of the cell chemistry, or the cells. Somebody call it explosion. It's no explosion. It's thermal runaway. Where maybe one cell starts to react, and then it's a very slow process, And the latest technology, again, Cybertruck, Monroe video, they're prohibiting that. Are the charging infrastructure standardized in the world? Yes, but it depends a bit on the continent. Take, for example, Europe here. There is a so-called Type 2 plug. And fast charging is latest the 350 kilowatt. If you go to Japan, for example, there is a more Asian standard there, which is CHAdeMO. It's a different plug. It's a different kilowatt. Although the latest, it looks like that this is maybe an outdated model and more Type 2 wins. If you go to the US, the Tesla charging plug became the standard, the North American charging standard, as they called it. Why? Because obviously they have the biggest charging network. Other car companies wanted to plug in with their cars into that network at the beginning with an adapter, but then they would install also the plug at their electric cars, So it depends a bit on the region, but it's much more standardized than when we started off in 2009. A question from Eva: what are the mechanical losses typically associated with electric drivetrains, and how are they mitigated in high performance in EVs? So the great thing about the mechanical losses is Also, they are much less. Why? Because mechanical losses is when there are a lot of mechanical parts in, and that is something you don't have in an electric car. You basically have the electric motor, and then you have a transmission. It's one gear. While in combustion engine cars, you have typically 5, 6, 7 gears, then reverse gear, and so on. So there are much more mechanical parts there, and that causes much more mechanical losses. So the electric, there's nothing more efficient than an electric drivetrain. And I discussed before already the efficiency of the electric motor. So I think that's covered. Engineer Rudat, you're a good teacher. Well answered question. It's not okay. Thank you so much. thank you, Reggie, for that nice comment. Appreciate it. For the countries, for the countries with extreme heat, there was a question. Let me go back. That's great because the last 2 years I was involved in Saudi Arabia, where we have in July and August up to 50 degrees Celsius. 50 degrees. So you're jumping out of your car, you immediately look for shelter and protection in office or in your hotel or wherever. You know, it's incredible. That's why, by the way, people in the Middle East, they have per capita the highest energy usage. Why? Everybody has air conditioning at home and they run it 24 hours nearly, right? So that's why their consumption, the base consumption, is already much, much higher than in other parts of the world. Yeah. Anyways, so what does extreme heat mean for electric cars? I was involved there in an electric car project, and obviously we discussed this a lot there. The answer to that is like Tesla, what they're doing, which is overheat protection. So I parked, for example, my car outside of the office one day. It was 50 degrees, nearly 50 degrees. And when I came back 5 hours later, the air conditioning was on. Why? Because to circulate the cooling water and cool the battery down to avoid that it has any damage to the batteries, right? And then I would say that more local players there, or players in general going to the Middle East, they do a lot of hot weather testing. They think about increasing their cooling systems. They think about increasing and improving their, from air to water cooling, not only for the batteries, but also the electric motors and so on. So there's a much more focus on the cooling itself, which is not necessarily the same focus in other countries. Having said that, each and every car in the world, they go through extreme weather testing. That's what you may see in like that cars are taken into the deserts of the world, although they're not thinking about introducing that car in that country. Cars are taken to the North Pole, or to the coldest regions in the world, like Russia, Siberia, or so on, to do also cold weather testing, because every country may have like an extreme weather event, right, one day, and that's why cars want to be tested and prepared for that. Lydia asked the question, how long do EV batteries last? So the life of a battery is typically very, very long. Car manufacturers give up to 8 years normally a warranty. Typically depends a bit on the usage. There's then 70 to 80% capacity still left. And then customers will decide whether they trade in that battery for a new one. The old one gets recycled or in a second life project, for example. But yeah, I would say everything 8 to 10, 11, 12 years, is possible, but not the same 100% capacity than the beginning. And then the last question we have here, Victoria, thank you for that. The batteries are lithium in case of a thermal incident. Does one use water to quench the fire? Today, state of the art is lithium-ion batteries. We are coming from lead batteries. They come with memory effects, much less energy density, much larger, much more heavy. So that's nothing you want to see in an electric cars where you want to have the advantages like I mentioned before, low center of gravity, weight distribution, and so on and so on. So it's lithium indeed. And the where was the second? Use water to quench. No, you wouldn't use water. You basically have to use special chemicals, powders, to die out the fire. The next question is, lithium expensive? Is this cost going to change? Yes, it changed already. I told you this story, Jeanette, at the beginning, where I had my first conversation with a young Elon Musk. The kilowatt hour was $1,200, $1,300 US. And today it's more 100 US dollars per kilowatt hour, and it's still falling. So what happens here? It's obviously economies of scale. The more you produce, the cheaper the process, manufacturing costs, etc. You can distribute all that on a higher quantity, economies of scale, right? But there's also like a next-gen battery technology out there on a material which is called sodium, a salt, much more abundant, 10 times more abundant than lithium, and less toxic, more distributed across the world. This is important because right now, around 80% of the value chain for batteries is in China. So basically, a lot of jobs are generated and created in China. But actually, I'm more interested to generate jobs where the jobs are needed and where the economies are, right? So electric cars which are sold in Europe should generate European jobs. Electric cars which are sold in Africa should generate African jobs, and not just 80% in China. So that's why I'm a big believer of the next technologies like sodium, like the salt, much more abundant, also more locally produced. Battery second life or end of life. I'm in the board of a battery recycling company. And we discussed this a lot. At the beginning, there was high hopes for second life projects. But the reality is, what we're finding is that the battery prices, they become so low that, because second life, that was simply based on the idea, it is so expensive to not throw it away afterwards. Can we do something again with it? But now the latest batteries, they are already cheap. We discussed this, right? $1,200, whereas $100 per kilowatt hour. That second life use cases are not as needed as discussed as before, right? This is one thing. And then in the battery recycling company, we discuss when you have 60-70% capacity after 8 years, it already makes sense to break down the battery into lithium, into nickel, into manganese, and so on, and then build a new battery which has again 100%. So I think it was more like a very good initial idea for getting this industry, this business kick-started when battery price was high, but now it fades a bit. It's getting less and less importance, given the battery prices are coming down. I'm new to EV. I'm really learning a lot from the question. Thanks, ladies and Angie. Okay, thank you for that comment. Really nice. Then what about the maintenance of the battery and charging system? Yeah, very good question. Thank you so much, Grace, for that. So battery maintenance is important. It comes with charging in the right areas that avoid like the 2 stages I mentioned, not depleted completely, not charging and then standing around. Also like temperatures and the cooling, you want to respect that. And then the charging system as well is, I have a friend who's actually CEO of a charging company. And he said the first thing he did is he asked, when he was new to the company, and it was just last year, he asked, where's the maintenance department? Everybody looked like, we have no maintenance department, we install it and then we forget about it. And he said, no, we changed this because there are failures, there are parts which need to be replaced. You know, there are cables breaking and so on and so on. So there is a business around it. I would say on a yearly base, 10-50%, you know, where you need to take care of charging stations as well itself. Capacity of lithium battery assembly in a single car depends a bit on the capacity of lithium. Okay, lithium is typically a small part of the battery. It's more like a few percentage points, so to speak. If we said before a battery is maybe on average 500 kilograms, you know, if you take 20-30 kilograms is lithium, that's a rough give or take, you know, you can say. There are obviously new technologies, you know, with every technology, with every approach, it changes a bit. One is higher, one is lower, but yeah, roundabout, you're not wrong with that. What are the common faults in EVs and the repairs to be done in the components? A good question, very good question. I have to think a bit about it. The common faults in a combustion engine here in the Western world today, most faults above 50%, they are electronics. The different ECUs, the different steering units, computer units, right? For example, and so on and so on. You want to open your you want to open your car with your key fob and it doesn't open, stuff like that, right? And this is also true for the electric car. But the electric car is much better when it comes to drivetrain problems. Why? Because lower parts, lower service needs. That goes back to what we discussed a bit before. Combustion engines on extreme can cause car damage. What are some of the parameters put in place in EVs to ensure the same scenario doesn't occur? Yeah, I would say it's cooling, water cooling systems. Yeah, this obviously takes more energy. Yeah, let's face this as well. When I'm in Saudi with my Tesla rented, then obviously the air conditioning is always on, right? But it's not the case here in Germany, maybe, or so, or in London. So it takes a bit more consumption. But for a combustion engine car, you would also switch on the air conditioning, which is based on gasoline, and so there's no difference to that. But it's just simply managed. Then engineer Reggie, I'm a mechanical engineer, planned option, working under the Ministry of Roads, but I think you guys, especially our able engineer Rudat, can organize for training, even if it's 3 months. We carry out some practical. Thank you for that comment. I'm actually happy to do that. Please reach out to me on LinkedIn. You know, if you have any questions or projects or ideas, you know, I'm very open to that. What type of coolant is used in the battery? Yeah, great question. It's not just water. It's a special liquid, special chemicals. There are obviously chemicals. I mean, it is a water base, but there are chemicals added. Chemicals which take out the heat much better than you know, just water would do or would evaporate and create a lot of pressure in the cooling system. You want to avoid that. Yeah, but there's not so much. From my experience, there's not so much difference than with a cooling liquid from a combustion engine car. How do EVs impact the environment? What role do they play in reducing greenhouse gas? Great question, Besetta. Thank you for that. So per definition, an electric car has no exhaust pipe, has no local emissions. 5 minutes. So if you go with an electric car in a city center, pedestrians, people cycling, people who are there, they do not have to suffer from exhaust pipes, right? So no tailpipe emissions. That's great. Somewhere else, the electricity needs to be generated, right? And that can be, and it made most sense, in a renewable way. Solar panels, water, hydro. We discussed a bit at the beginning about it. And then obviously it's really a great system. There are studies out there, even if you burn oil to generate electricity, to drive 100 kilometers with an electric car, oil burned electricity, or 100 kilometers with a gasoline car, the oil-burned electricity is still a lower amount than a gasoline car would consume. Why? Because the system is obviously less efficient than a huge plant, a huge utility. So, and given that governments in the world, they're all investing left and right in renewable energies, from today, you can only say with an electric car, every day it gets better and better and better, you know, and you don't have to do anything. Why? Because the grid gets cleaner and cleaner through the government, through renewable energies, getting plugged into the grid. And if you have the capabilities, obviously it makes so much sense to install also charging, solar charging or solar panels at your home. So you generate your own electricity. They are very cheap solar panels, as you know, from China. They have an overcapacity right now. You can set up for little money, comparable little money, solar parks with those panels, you know, and to generate more local energy and electricity. Yeah, and that's why it has a fantastic effect, obviously. So the last question, Monga, do EVs handle extreme weather temp? I think we covered that already. More cooling needed, right? Or in the case of a cold country, more heating needed because the batteries, they have an optimal operational temperature of 20-25 degrees Celsius, right? If you go significantly below or higher, you know, obviously it's not optimal. So the system itself keeps it on 20-25 degrees Celsius. How long does it take to charge, and best time recommend for charging? Great question, Olivia. Thanks. So as mentioned, you can charge at home 11 or 22 kilowatt per hour. It means you add 11 or 22 kilowatt hours. If you have a 100 kilowatt hour battery, you need 8-9 hours or 4 or 5 hours, right? And this is also like a way to charge on a daily basis. Very simple, very easy. You likely even don't need to charge that long because you drive rather 50-100 kilometers. At least that's the experience we have here from all the 100,000s of EV drivers in the world. And then this is the recommended way to charge. Slow charge is better for the battery life. And obviously at home, you don't have to go out. By the way, we haven't discussed even that. Through me driving for a decade now electric cars, I can tell you on one hand, on all the fingers I have, how often I've visited a gas station. And this is more because of buying a Coke, you know, or maybe, I don't know, buying something else there, right? Not because the need. I saved a lot of time, you know, instead of going, you simply just plug it in overnight and then it's fully charged. A bit like, the experience is a bit like your phone, right? Once you're convinced, once you bought it, you don't even, you know, you don't ask yourself, is it 1 hour charging, 2 hours? You know, next morning it's fully charged, right? Then there is fast charging. Fast charging makes a lot of progress. Latest technology is 200-300, 350 in some use cases, kilowatt. So basically in 15-20 minutes, the battery is 80% full. Why 80? Because the last 20% you cannot go full throttle in, you know. You typically go between 20 and 80, you go full throttle, and then you slow down because the process-wise you would otherwise affect even stronger the battery. How are EVs still better than other vehicle types in country which might face extended load shedding or power outage? That's a great question, Sivyangi. I think you have to really consider it as a complete system, like a smart grid, where maybe the view changes from just plugging it in to rather having it also like an extended storage, for example. But I would totally agree. In some countries, there's a discussion about introducing electric vehicles, installing charging stations, and stabilizing the grids. And by the way, I'm also talking about the US here. The US has a very old, partly in some parts of the United States, a very old grid system, you know, where the cables are above the street and falling down and whatnot. So that obviously also needs to be improved. If you have the capability at home, that gives you a lot of freedom. Why? Because you install the solar panels, you have home storage, and then you can even have an off-grid system. So you are less dependent on power outages, for example. One thing to note, I don't know how long power outages are in your experiences, but if they're hours or so, it would likely mean in that hours you cannot charge, but the rest of the time you can charge. Maybe in that environment, you would make sure that your car is always fully charged, you know, or the majority is charged, just to be flexible, just to be prepared. So I would say it also changes a bit maybe your behavior when you can expect every week or every whatever power outage. Yeah. Then Reggie, is it advisable to smear the battery terminals with Vaseline or rather grease the way we normally do our traditional machines? Obviously, there's no oil greedy needed for battery system. It's really more service maintenance is more done like with your iPhone or computer. Janet, has solar been incorporated into EVs, especially in off-grid charging? Does EVs have a backup charge source apart from regenerative braking? Yeah, totally. First projects like that are coming. It's here in Germany, for example, right now, it's a big thing to talk about the so-called bi-directional charging. So you can, from your solar panel at home, you charge your car, but then in the evening, you can take your battery of the car and you use that for everything you do in the house, right? So the first projects like that are coming and they make a lot of sense. Are there a couple of more details to be figured out? Yes. Car manufacturers, they realize that then the battery is used more than their original business case was anticipating for car usage, right? Suddenly use it also overnight. There is no break, if you will. There's no pause for the battery, so to speak. So they're thinking about what does it do to the warranty, what does it do to longevity of the battery and things like that. But definitely the industry is moving forward in that direction to be integrated, and new technology allows that. How are IoT incorporated in EVs? I'm interested in such projects. Catherine, thank you, fantastic question. Obviously, the Tesla, other EVs, they are more computers. You have all the heat, you have all the information, all the KPIs of the stage of the car, what it is, what it has. So I would say that's a very nice playground for IoT projects, much better. You can even access it partly with the OBD onboard diagnosis tools and plugs, make it visible maybe through an app and so on. So I think a very nice playground for that. Zevyangi, a question: how can African countries begin this difficult journey of transition? Great question. Great question. I'm in the African group. I think since the beginning of the year in NEF Africa, thanks to God, I got here invited, and I'm happy. And I think God is doing an incredible job here with the wider team of educating people. Everything starts with education. Everything starts with talking about what's happening in other countries and so on and so on. So I think this is how you and each of you could support that. Then when it comes to creating really facts, you know, I would say it needs to be on the agenda of each and every government. I'm actually quite inspired, and please help me with comments here if you see the same way or so. But I'm quite inspired by the announcement the Kenyan government just did recently. I think I would say of 2, 3, 4 weeks ago. they announced they are buying 1,000 electric vehicles and more over the next years. And they would supply those 1,000 electric vehicles to their ministries, right? To their different authorities and ministries and people working there, and hence start by doing and driving the electric agenda and the transitioning. So I think you need like these forward thinkers. This can be governments, but I have also seen in other countries, you know, countries I built for Tesla, you know, for example, that you have opinion leaders in some countries. Opinion leaders maybe are fluent people, you know, people who have the money to buy a Tesla or who have the money to buy an electric car because it must be new and it's more expensive and so on. And then like that, start to bring a bit pressure on governments as well to think about charging and to think about more sustainability. So I think it's the government, I think it's opinion leaders, I think, and then I think it's through communities like you have built here, and maybe also startups, you know, who are building things. And that's, I want to remind you, Gart and myself, we are really thinking, how can we install a fast charging network in the different countries, for example, in Kenya. If you, by the way, know other governments, other countries who are buying electric cars, who are moving forward with electric cars, I would be also quite interested in that stories, you know, contact me for that. Also, if you have projects where I could speak, or, you know, I can maybe educate people, help, support, I'm very happy, and I'm very approachable for that. Tesla was never a job for me. That was always a mission for me, because as mentioned, there's a lot of motivation going electric by going sustainable, avoiding carbon emissions for my two daughters and for my family, and for saving the planet actually by doing good things. Yeah. Hey, and I think having said that, there's no more question. I talked, oh my God, now for over an hour, I think 120, 130. Thank you for all these engaging, exciting questions. I'm really thankful also for all these comments, that you enjoyed this session. Let's reach out afterwards. Thank you so much.
Thank you, Engineer Rudat. We really appreciate you. You can see the claps from the ladies. They're clapping for you. Really, very happy for the session. They really kept here. We maintained about almost 100 or more all throughout that hour. They were here listening. We appreciate you greatly. And on behalf of them, we say, really what you're doing and what GAD is doing and the other directors in African EV is such a great thing. And the ladies need to be part of it and own it and be at the front line. The possibilities for getting jobs, promotions, and actually being at the front line in these transition shift conversations. They have a place at the table, and now they have seen this, they understand it, and our prayer is that when the practical trainings are coming, they will be able to be there. So for the senior engineers in the platform, Liri, we will want to hear from you about the possibilities of collaborating to do these practical workshops for these ladies. And now I want to hand over to Gad. Thank you.
Hi, everybody. I think it's been good. We've had issues with people struggling to connect the session. This is the first time we're using. Can you hear me? Can you hear me?
No, you need to be louder.
I'm saying that,
come nearer to your mic.
No problem. I'm saying that we've had issues. Can you hear me now? We've had issues with people struggling to connect to the platform. Things is famous for people sometimes when they want to join. So it really affected the numbers. But tomorrow we'll be having the Friday group for this session. I believe Jochen may be around for that. Looking at the interest in the questions, I was quite impressed with the questions and all that. I think tomorrow, hopefully, we'll also hear some of the ladies speak. I was looking towards that, but I never got that. I never got to hear anybody actually speak because the questions were just coming hard and fast in the comments. So thank you, ladies, very much. Next week Thursday, so your cohort is Thursdays. So every Thursday still. So for the next 2 Thursdays after this, we'll be having our regular meetings. The link is the same. It is scheduled for every Thursday, 1, 2, 3. That is what the distance is about. And the time is also 1. Please, there is no morning time or evening time. It's one time that is applicable for different time zones. Like right now, it is 4 o'clock in Kenya. For those in Zambia, it's 3 o'clock. And for those in Nigeria, it is 2 o'clock. And of course, for the rest of us here in West Africa, it is 1 p.m. plus change. Thank you very much. If you have any questions, drop them on the chat. We'll be sending you some mails and some WhatsApps about some videos and stuff that you have to watch. Like Jochen alluded to, next week is a bit more technical, like I said. So prepare for that. The videos will come to just give you prep for that session. We'll be having Olukokum next week. Thank you, everybody. Can you all turn on our cameras? Let us take a
yes, please. Exactly. I wanted to say that as well.
Screenshot.
Everybody on camera. Everyone on camera, and we take
Yes.
a screenshot and a picture. Yes, nice idea.
Let's see.
Oh, that is the best background, Evodia. Thank you.
I can't see it. Let me see. Gallery. You try together mode. Which one is together mode? I think I've done something wrong. Is that the correct thing? Wait, is this nice?
Everybody has to look in the camera and wave their arms or hands. Then it's even better.
Okay.
Great.
I'm taking this.
Yeah, hands up.
I just want to take a screenshot.
Great. Thank you. God, you need to look in the camera as well.
I take the screenshots. With as many people as possible, we should take a screenshot. Then you drop it in our group chats.
Great. Thank you, guys.
Okay, please, 1 more minute. Let me change that to gallery. Oh, okay. This is not everybody. So let me try this. All right. Thank you very much. See you next week, Thursday. For those who are not able to join today, some of those who cannot join, we'll try and see if they can join tomorrow's session. But if everybody reports for that cohort, they will not be able to join. Bye.
Thank you. Goodbye. Have a great day. Thank you. Bye-bye.
Bye-bye.
Bye. Bye.
Bye-bye. You're welcome.
Bye.